All right, this video is going to be a demonstration of using Gaussian elimination and back substitution to solve a system of linear equations. If you're already familiar with the topic, again, this video is just meant to be an example or a demonstration. If you're not familiar with how to use Gaussian elimination, you may want to watch one of the more intro videos that'll discuss the major parts. But again, we've got our system here. We've got three different equations, three different variables, so there's a good chance that this is going to be a consistent system with hopefully an independent answer, right? A single answer. You'll notice I've labeled all three equations already, A, B, and C. That's just going to help me keep track of sort of what I'm doing. Now, our goal is to make that upper left corner, first of all, into a 1x. Now, that can be done in a couple of different ways. If there were an equation with a 1x, we could just slide it into place, right? We could just move that equation into sort of equation 1, right, or row 1. We don't have that. We could multiply an equation by a fraction, so maybe like the bottom equation, I could divide everything by 2. Now, unfortunately, that means I'd get a few different decimals, but that wouldn't be terrible, right? Some 0.5s aren't horrible to work with. What I'm actually going to do is go ahead and subtract. I'm going to take equation A, and I'm going to subtract equation C, and actually produce a 1x, all right? That 3 minus that 2, if we actually went ahead and just said A minus C, which again, I'm going to give it a new name, so I'm just going to call that equation D, but 3 minus 2 is going to be 1x. 4 minus the negative 3 would be a positive 7y, and negative 1z minus 7z, remember I'm subtracting, so negative 1 minus 7 is going to be a negative 8z. 17 minus the negative 21, 17 plus 21 essentially becomes 38. So again, that's equation A minus equation C. Right? And again, it's never a bad idea. You can do that work off to the side if you'd like. I'm going to move fairly quickly, so I may do a little bit of side work, but in this video, I'm going to try to do a lot of the work just sort of looking at the previous equations. Now, the next thing that we want is to eliminate some x's. And since we already combined A and C, what we're going to do is use our other equations. So probably A and B or B and C. Let's use our other equations to eliminate those x's. So if I'm looking at equations A and B, and I want to get rid of x, I would like to make them both into 15. So what I'm going to do is multiply equation A by 5 and equation B by 3, but at the same time I want to subtract because I want that 15 minus 15, right? Again, I'm going to give that a new name just so I don't forget. We'll call it equation E. But let's go ahead and go off to the side. This would be 15x, right? I'm going to multiply equation A by 5, so 15, 20, and 5z here, and multiply 17 by 5 is going to be 85. Then we can take negative 3b, and I'm going to go ahead and put the negative in there. Let's call it a negative 15x, positive 3y. Again, multiplied by negative 3 would be a negative 6z, and by negative 3, that's a positive 6. That way, if we go ahead and add, again, the x's are going to disappear. The y's are going to become 23y, so I'm going to go ahead and write that over here in my system. Negative 5 and negative 6 makes for a negative 11z, and 85 and 6 would make for 91. So that looks pretty good as far as that goes. Then let's go ahead and finish that third equation. Well, I used A and B, we used A and C. We'd really kind of like to combine equations B and C. So let's go ahead and make these both into 10. So again, I'm going to call this 2b, or not to be. That's the question. I'm just kidding. That's an English thing. Minus 5c, because again, that's going to make for 10x, right? I'm going to multiply equation B by 2, minus 2y plus 4z, and will be equal to negative 4. And I'm going to take negative 5 times equation C, so negative 10x plus 15y, right? Negative 5 times 7 is going to be negative 35z, and negative 5 times negative 21 would be 105. Again, we'll go ahead and add those up. The x's disappear. We get a 13y. We get a negative 31z. Right? Make sure we can read that 31. And a 101 down there. Now, you'll notice our numbers are going to get fairly large fairly quickly here. So that's going to get a little bit messy, but again, we're well on our way. We're in good shape as far as that goes. Again, I'm going to give that one a name. We'll call that equation F. And now let's go ahead and move on down to our next system. Now the beauty is, again, with the Gaussian elimination, we'll never have to look back. So I'm going to go ahead and get rid of these side notes so we've got plenty of room to write. But again, we'll never really have to look back to those previous steps, back to the originals. All right, we like equation D. We like that idea that it's x alone. So I'm just going to rewrite that one. All right, so we've got that all written out. Make sure it's readable there. Then, now this one's going to be a little bit tricky. We need to make y into a 1y. So whether we take that last equation and we divide it by 13, or we take equation E and we divide it by 23, either way it's going to get a little bit messy. So I'm going to go ahead and just go with 1 over 23 equals equation E, right? And that's going to go ahead and give me a y, right? 23 divided by 23 would be 1. And I'm just going to get some fractions here. So we'll just deal with that. Negative 11/23 z. I don't recommend rounding off to decimals, purely because, again, we're not going to want to round things. We're not going to want to be inexact. We'll call that one equation G. Right? We don't have an equation G yet. And then down here at the bottom, again, if that's the case, we've got our 1y. Oops, sorry, I bumped the screen there. We've got our equation y, right here. Well, we need no y to be below it, right? We need nothing below it. We don't have any other x's. We don't want any other y's. So what I need to do is get rid of this 13. Now, here's where it may get a little bit messy. Kind of like we did up top, though. When I had 5 and 2, I just looked for a common multiple. Well, 23 and 13 really don't have a great common multiple. They don't really go into anything together. We're going to have to make them both into, it looks like, 299. So that's really fun there. And I'll do that by taking equation E, right? We're going to take equation E, and we're going to multiply it by 13. And I'm going to take equation F, and we're going to multiply it by 23. We're just going to multiply those two numbers by each other. Since they're both positive, let's go ahead and subtract those so that we end up without a y value. So we'll just get our calculator ready and handy here. 13 times 23, again, was 299. So we're going to need 299, right? Y. 13 times negative 11 is going to be 143, so minus 143, right? 13 times that negative 11 from inside of that equation E, right? So negative 143, and that's Z. And then in the end, 91 times 13 is going to be 1183. Now, I know those numbers got large, but just kind of keep following it. Don't let the numbers bog you down. We now need to take 23 times equation F, right? So again, 13 times 23, and a negative 23 at that will be a negative 299. Then we want to take negative 31 times negative 23. We're going to be 713 Z. And finally, 101 times, again, negative 23 should be a 101 times negative 23. Again, negative 2323. Makes sense. We'll add those up. So basically 713 minus 143 is 570. So we have a 570Z, and we have 1183 minus 2323, which is negative 1140. One last set of equations here. We'll just take it up top. Again, we've got equation D. That's x plus 7y minus 8z equals 38. We've got G. That's y minus 11/23 z equals 91/23. And finally, well, if this was equation H, let's call it, right? What I really want to do is take equation H and divide away that 570. So I'm going to take 1 over 570, right, times equation H. so that we get 570 divided by 570, well, that's z. And negative 1140 divided by 570 is simply negative 2. All right? If we get rid of this side note, so I've got a little more room to write again. All right? We now know what z is. So let's go ahead and back substitute y minus 11/23 times negative 2 equals 91/23. Well, y plus then 22/23 equals 91/23. And if we subtract, well, 91 minus 22 is going to be 49, right? 91 minus 22, sorry, 69 divided by 23, which is 3. And we've got our y value. And we'll back substitute one more time. Again, you go back to any one of the original equations, but again, I'm going to go to equation D right now. X plus 7y minus 8z equals 38. But again, I'm going to take out the y and the z. Right? So we've got that, again, 7 times y minus 8 times z, x plus 21 minus, or make that plus 16, right? So 21 plus 16 is going to be 37. And if we subtract, x equals 1. A great idea is always take your answer, plug it back into each one of your equations, and you can check your answer. That coordinate, 1, 3, negative 2, should make all 3 equations true. I hope that helps you again with Gaussian elimination. I know it's a long process, but again, I hope that clears things up for you a little bit. I know it gets a little messy with the fractions. Don't let the numbers bog you down. Simple arithmetic. Make sure you line the numbers up, add, subtract, and multiply all carefully, and hopefully you can find your answers. Have a great day.